Hi, my name's Joe Hinkle. This training video is one that I missed. It is hopefully will fill a big hole when it comes to how to configure the HinksPix PRO for smart receivers. This video will be specifically on configuring the 4-port SPI smart receiver. There's another video that I'm also going to release today, which will be on the 16-port SPI. The hole that I found that I had in my training was how do you configure or stack or organize the data that goes out the particular smart receiver ports so that they actually agree and you illuminate the display items that you want to illuminate. So first off, you need to make sure that you update your HinksPix PRO. Either plug it into a internet connection or use my HSA program, which can put the latest firmware on a micro SD card, and then you can put the micro SD card in the controller and it'll update itself. The key thing is you want to be on web version 64, which is I'm on the status tab. So web version 64. So let's begin the training. We're going to start off effectively with a vanilla controller, which will come up as 16 universes at 150 channels per universe. So that's 50 pixels. Now, I'm doing things a little non-standard. I find that when everything is basically standardized, some people come to believe that some of the correlation between universe numbers and other things have to be that way. So this particular video, if you've noticed, I've started my universe numbering at 20, not at 1, so that you can try to get an understanding of what you need to do. Okay? Now, just to go over very quickly, these two columns, universe number and channel per universe. These tell the controller what E131 packets to look for that your sequencing program, whether it's LOR or whether it's Xlights or whether it's Vixen or whatever, is going to be transmitting. When the controller sees a specific universe number, it looks in the placement order and it places in memory. This is how it's placed in memory, which seems a little technical, but you need to understand that when this data is placed in memory in this organization, these channel start numbers are what's important when we get into configuring. Okay? So let's go, and for this assumption, we're going to go, we have a long range transmitter here, which has got 4 Cat5 cables. I'm going to suggest you grab a piece of paper and a pen and just take some notes. I'll tell you what to write down. The reason is, normally, if you notice here, we have ports 1, 2, 3, and 4. So if you were just hooking a dumb long-range connector, anything coming down this particular twisted pair, these are actually 4 twisted pairs in the Cat5 cable, they're going to port 1. So they're labeled port 1, 2, 3, and 4. And that's what's labeled on the dumb long-range receiver. When you get into smart receivers, there's more than just that coming down. So for this example, I want you to think that you've got 8 leaping arches. We got a group of 4 leaping arches, and 200 feet away we have another group of 4 leaping arches. So in our display, we want one smart receiver that's got 4 ports. Now, my definition of a port is very specifically where a pixel string connects effectively to that green Euro connector that's on the board. So it's a physical string to controller connection. That's what I deem a port. So on one smart receiver, we're going to use 2 of them, we are going to drive 4 of the leaping arches, and then we're going to put another Cat5 cable coming off of that smart receiver and have it go to the second one 200 feet away, and that's going to drive the next 4 leaping arches. Okay? So the first thing we want to do is we're going to press the plus twice, so we got 2 smart receivers here. And if you notice, one of the things that changed now, this is what is part of the new web change I changed, the header changed from the word port to the word stream, because port is no longer really indicative of what's happening. It's more of a stream of data, as you'll see in a minute. So here's our first smart receiver. There are 4 ports that are labeled 1, 2, 3, and 4. On your piece of paper, I want you to put on port 1, our first leaping arch is going to be universe 22. Our second arch, which is going to be at port 2, is going to be universe 23. That's 50 pixels being transmitted with universe 23. The third leaping arch is going to be universe 24, and the fourth one is going to be 25. Now, 200 feet away, we're going to have our next set of leaping arches. On port 1, that leaping arch, we've told, let's say our sequencer, whether it be Xlights, that's going to be universe 26. The one connected to port 2 is universe 27, 3 is 28, and 4 is 29. Now, hopefully you wrote those down, because here comes the first chance for a light bulb moment. The data that is coming on this port, on port 1 of the very first smart receiver, is running in front of the data for port 1 on the second receiver. So for a data stream, now remember I talked here about data stream. This one here, the data coming on stream 1 is available to this port 1 and this port 1. Well, remember, this port 1 was universe 22, and this universe 1 was port 26. So we have 50 pixels on this, we have 50 pixels there, so in total we have 100 pixels on this stream. So now we go to arch 2. This is universe 23. It is on the same stream as this one, which is 27. So we have the data for 50 pixels on 27 here. We have the data for 50 pixels on universe 23, and that's all coming on this stream. So this stream is 100. Hopefully a light bulb is starting to fire off. And the same is going to hold true with this. This is going to be universe 24. Following that is got to be universe 28, because they're on the same stream. So that's 100. And this one will be 100. So let's just do an autocalc. Now, it's important to realize, what did I say? Look at your notes. What is composed on stream 1? The first set of data coming off of stream 1 is going here, and that is universe 22. So we're going to start pulling off pixel 1. Well, after the first 50 pixels are pulled off, then we have the data on the same stream running right in back of that for universe 26, which happens to be pixel 51. So all the same. This will be 1, 1, 1. This will be 51. This will be 51. This will be 51. Again, light bulb moment. What I'm trying to convey is universe 22 has the first 50 pixels running down this stream. Following that, on the same stream, are the 50 pixels associated with universe 26. So this 50 and this 50 give you 100 pixels that are running on this stream. Let's save that. That's important. Oh, thank you. Let's make this, let's just make it 2 and 3. How's that? Not 0 and 1. There we go. Now we're going to save. So what we're going to do now is we're going to jump back over here because there's a couple things I want to show you. So now our job here is to make sure that those universes are sequential here. So the first thing we said was universe 22, which is 150 channels or 50 pixels. What needed to immediately follow 22? Look at your notes. Pause. Light bulb moment. Remember, what are the two universes that were on stream 1? Universe 22 followed by universe 26. This needs to be 26. Then we went to the second stream, which was universe 23 followed by universe 27. Then we had universe 24 followed by universe 28. Then we had universe 25 followed by 29. So now, if you look, we have 22, which starts at 301, ends at 450. Immediately following that in this memory map is universe 26. So we now have the data for universe 22 immediately preceding the universe data 26. The same for 23 and 27. Let's save that. Now there's one more light bulb to go off. If you notice, we started over on universe 22. Well, where is 22 in this memory map? It's actually position 301. So we have one last thing to do to properly configure these two smart receivers. So we need to remember 301 is the beginning of universe 22. So we need to come back to long range. And I did this purposely. See, this said automatically it starts at channel 1. Well, in our case it doesn't. It starts at channel 301. Do that, do an auto calc. And now everything is properly configured. We can save that. Now, if you notice, universe stream 1 consists of data here, which was universe 22, immediately followed by data for universe 26. So channels 301 to 600 were 22 and 26 that were coming down this twisted pair, coming out that port and that port at pixel position 1 at pixel position 51. Let's just double check. 301 to 600. So we can come back here. (22) 301 to 600. 600 is the end of 26, and 301 is the start of 22. So we have the two data packets properly positioned in memory so that they go out the output stream. I know this is very technical. Hopefully you took some notes on paper and pen. Don't be surprised if you need to go through this video multiple times. That light bulb will go off, and when it comes on, you'll say, oh my goodness, I understand it. It's pretty simple. But until that light bulb goes on, it can be a little frustrating. That's going to conclude this video on the 4-port Smart SPI receiver board. Please look at the video on the SPI-16. It actually contains 4 of these Smart 4 receivers and how they're programmed. Have a nice day and have a great holiday. Bye. Hello, my name's Joe Hinkle. This training video is specifically on the 16-port Smart long-range receiver board that runs with the HinksPix PRO. Now, in order for what you're doing to be what I'm doing here, you need to make sure that your controller has web version 64 firmware installed. If you don't, plug the controller into a Cat5 cable that has access to the internet and it'll load itself, or use my HSA program, which will transfer the files to a micro SD card, which you can then take over to the controller and it'll program itself. So to begin, now this is going to be a somewhat technical training. What I suggest you do is get a paper and pen, because I want you to take some notes, because it's going to get a little technical. And the light bulb might not go off right at first, so you may have to watch this video several times before the light bulb clicks and it's like, oh, this stuff is simple. Until that point, it might seem a little complicated. Okay? Now, I'm also going to not do as a standard video. We're going to drive a megatree, a 16-string megatree. Those 16 strings have 50 pixels per string. So if we were going to use a standard SPI port, which in the past is what everybody has used for driving megatrees, you have 16 ports, and you make a string connection to each of these ports, and your software drives each of those ports directly, and it's fairly straightforward. This is the background you're coming from. But when we're dealing with long range, we're not dealing effectively with 16 individual data or ports. We're dealing with 4 because they're coming off of one Cat5 cable. We'll get into that in a minute. So let us also not start at universe 1. Let us start at, no, we'll start at universe 1 so we don't get real complicated. So we're going to do 16 universes at 150 channels per universe. That's 50 pixels. And that's going to give us our megatree. Okay? So, coincidentally, universe 1 needs to go to port 1. Universe 2 needs to go to port 2, 3, etc. Okay? So let's go over to our long-range board. Now, we're using a smart long-range receiver for the HinksPix PRO. That has actually embedded 4 of my smart receivers. Now, I've updated my software for the web page, and I'll show you. So, remember I said we normally drove 16? Well, there's 16 ports, and if you were just to hook up 4 dumb long-range receivers, it would be, you'd have 16 ports. My definition of a port now is where a string connects to that green Euro connector on one of your controller boards. To me, that connection is identified as a port. But for smart receivers, we can put multiple ports on, let's say, these 4. So the first thing we want to do is we want to add a smart receiver. Now, when you're dealing with the 16, there's only 4 IDs that you can use for the Smart 16. 0, 4, 8, and 12. Those are the only 4 IDs you can use because it automatically is going to take the next 3 and use them also. So for this example, we're going to start at 4. And this is identified as a Smart 4 port. We don't want 4 ports. We want a 16 port. Now when you do that, if you notice, it automatically added 3 more smart receivers. It automatically adjusted the ID in sequence. And remember this header up here? It used to say port. It no longer says port. It now says stream. And that's because it no longer, this 1, which happens to be a twisted pair, no longer contains just the data for port 1. It actually contains data for 4 ports, which we'll get into in a minute. And the software automatically identified which of the ports are coming off of each of the smart boards. Okay? So you can think of these port numbers as you normally would on a standard 16-port SPI board. So now we're going to start getting into the tricky stuff. Okay? So port 1. This is going to be universe 1. That's going to go to the port 1 for our tree. Now port 2 is over here on this board. But they're both on the same first line. So this data is in this stream following this. So let's back up. This stream here contains the data for ports 1, 2, 3, and 4. Okay? Ports 1, 2, 3, and 4 are all contained in this data stream, which is coming on 1. So this is going to be universe 1. This will be universe 2, 3, and 4. So we have 50 pixels on this, 50 here, 50 here, 50 here. So we have 200 pixels that are on this data stream. And hopefully you can make the leap. You're going to have 200 pixels on all of them because each of them is going to take 4 strings. 4 times 50 is 200. Okay? So this is going to be universe 1, and we're going to want to start at channel 1. The very first pixel that's coming on this stream is going to come out here. This is universe 2. Now, it's going to be starting at pixel 51. And it needs to follow that. Universe 3 is going to be 101. And universe 4 is going to be 151. Now, the important thing here, and coincidentally, I want you to go watch the video on the Smart 4, because this is going to come out fairly nice, because it's all going to be associated very nicely in the E131. On the SPI 4, on the Smart SPI 4 board, I changed things around so they're not going to be as nice. Okay? So, understand, the first 50 here, followed by this 50, followed by this 50, followed by this 50, are all on that stream. Now, port 5 starts on this stream. So the first 50 there is going to come off. We're going to take the universe 5 at pixel 1. Then this will be pixel 51. And these will all be exactly the same. We'll just make these all ones. These are 51s. These are 101s. $151. Now, that seemed pretty simple. Let's save this. We need to do an auto calc because we changed our pixel count. So, right now it says we're going to go from channel 1 to channel 2400, which is going to be 800 pixels, and they're going to be coming out these particular ports in this order. Save that again. Now, stream 1 is from 1 to 600. Stream 1 contains universe 1, 2, 3, and 4. Now, coincidentally, just because we organized it that way over here, it's going to be already properly sequenced, because universe 2 follows universe 1, 3 follows 4, so we go from 1 to 600 is all on stream 1. Now, this example was set up to be fairly nice and easy, okay? Go watch the one on the SPI-4 board. I purposely did not make it so these are sequential. You need to go look at that to make sure you fully understand how you have to make sure that these data streams, the data coming on these data streams, very specifically, the data for universe 1, followed by 2, followed by 3, followed by 4, are all sequential, 1 through 600. That's going to conclude this training video on how to set up the Smart 16 SPI board. Again, don't be lulled into the trap that coincidentally these universes were already nicely sequenced. Please watch my video on the SPI-4 board, which would be just like only having these two, and you will see that under some circumstances you need to properly put the universes in proper sequence order to make sure the data is available on that data stream in the proper order to be extracted from here and from here. Boy, I hope I haven't confused you. I know this is very technical. Please watch the video several times. The light bulb will go off, I guarantee it. And when it does, you'll say, oh my gosh, I understand it. It's simple. But I guarantee if this is your first time looking at this, your eyes are going to roll in the back of your head and you're going to say, what the hell did I get into? But I thank you very much for watching the video, and I hope you have a great holiday. Bye.